Hello friends, welcome to my channel EVRD Mechanical Engineering. Today I am going to explain about engineering mechanics and its types. So first of all, what is engineering mechanics? It is a branch of science which deals with the behavior of the body under a state of rest or moving condition. So that is about engineering mechanics. So it is classified into mainly two types. First one is the statics, second one is the dynamics. So the static is a branch of science Static is a branch of science which deals with the body under state of rest. When the body is in rest condition, it is dealt with the body condition, that is called statics. Dynamics is a branch of science of mechanics which deals with the body in moving condition. So again the dynamics is again further divided into two types, kinematics and kinetics. So in the dynamics, it is a branch of engineering mechanics which deals with the body under moving condition. Moving condition means the force is caused to move the body. So here again the depends upon the condition of force, consideration of force. Dynamics is divided into two types, kinematics and kinetics. Whenever the force is not considerable, which caused to move the body, that is called kinematics. When we are going to consider the force which caused to move the body, that is called kinetics. So this is the difference between kinematics and kinetics. So this is about classification of engineering mechanics and definition of engineering mechanics. Today we are going to discuss about parallelogram law of forces. Parallelogram law of forces. This is very important topic in engineering mechanics. So this is mainly used to determine the resultant of two forces which are acting at a point. So it states that when two forces are acting in magnitude and direction represented by two sides of parallelogram, then the resultant will be the diagonal of parallelogram in magnitude and direction at that point. So suppose P and Q are the two forces acting at a point. So here we need to find the resultant of these two forces. So here the diagonal gives the resultant of these two forces. So mainly it is used to determine the resultant of two forces meet at one point. So now OP and OQ are the two forces meet at a point O. So R is the resultant of these two forces. So that is the diagonal of the parallelogram. Now we will see the proof. So consider P is one force and Q is another force represented in magnitude and direction by OA and OB of two adjacent sides of parallelogram. So extend A, which is parallel to OB, and extend from B, which is parallel to OA. So OA BC is the parallelogram, and join O and C. So OC is the diagonal which is used to represent the resultant R. So extend from C to extension of OA, that is D. Okay, here now you can observe here in this diagram, side OB is parallel to AC, so that OB is equal to Q. So whenever these two are parallel, AC also Q. Okay, let the angle between two forces P and Q is alpha, and theta is the angle made by the resultant with horizontal, that is with force P. Okay, so OB is parallel to AC, so that here the angle DAC also alpha. Okay, so angle DAC also alpha because of AC and OB are parallel to each other. Now in this diagram, triangle DAC and triangle DOC, two are the right angle triangles. So angle from triangle DAC, angle DAC is equal to alpha. From triangle AOB, angle AOB is equal to alpha. Okay, now from triangle DAC, from triangle DAC, sin alpha is equal to opposite side by hypothesis, opposite side is equal to CD by AC. So CD is equal to, it is equal to Q, sorry, CD is equal to, CD we have to determine, AC is equal to Q. So CD is equal to Q sin alpha, AC is equal to Q into sin alpha, CD is equal to Q sin alpha. Similarly, cos alpha is equal to opposite side by hypothesis, same triangle, AD by AC. So AD we have to determine AC into cos alpha. So where AC is equal to again Q cos alpha, AD is equal to. So CD is equal to Q sin alpha, AD is equal to Q cos alpha. Now I am considering one more triangle, that is equal to DOC. From triangle DOC, that is a right angle triangle. From right angle triangle DOC, as per the Pythagoras rule, hypothesis square is equal to side square plus side square, that is the rule of Pythagoras. So here angle DOC is equal to theta. So from this triangle DOC, I am writing as per the from Pythagoras rule, OC square, Pythagoras rule, OC square, that is hypothesis square, plus is equal to OD square plus OC square is equal to OD square plus CD square, OD square plus CD square. Okay, now what is OC is equal to, that is equal to R diagonal, R resultant equal, and from OD you can write it as OA plus AD, CD is equal to Q. Okay, CD is equal to not Q, AC sin alpha. So OC square plus is equal to OD square plus CD square, OC is equal to, OD is equal to OA plus AD, OD is equal to OA plus AD, you can write it. Okay, so in this OA we have P, OA value is equal to P, AD is equal to Q cos alpha, already we have written from triangle DAC. So OD is equal to R square is equal to OC square is equal to R square, R square is equal to OD square. OD what you have to write here, OA plus AD, OA plus AD whole square plus CD square, CD square. CD is equal to, we have Q sin alpha, that is whole square, Q sin alpha whole square. So now R square is equal to, what is OA? OA is equal to P, OA is equal to, from diagram P, plus AD is equal to, already we have AD value Q cos alpha whole square plus Q square sin square alpha. So from this we can simplify, R square is equal to P square p square plus q square cos square alpha plus a plus b whole square rule 2p cube cos alpha sin alpha plus q square sin square alpha. So you can split into a plus b whole square rule, p plus q cos alpha whole square, p square plus q square cos alpha plus 2pq cos alpha sin alpha plus q square sin square alpha. R square is equal to p square plus q square 2pq cos alpha. So from q square cos alpha plus q square sin alpha, q square is the common you can take common, q square common, if you take q square common, sin square plus r square alpha is equal to 1. So finally p square plus q square plus 2pq cos alpha sin alpha. This is the equation for resultant. R is equal to, okay. So from this is R is equal to resultant in magnitude and direction, okay. OC is the magnitude, okay. OC is the direction and R is the magnitude of this resultant. Like that we can determine the R value when you know the P and Q values which are at an angle of alpha. So this is about the parallelogram law of forces and proof of parallelogram law of forces. So this is mainly used to determine the resultant of two forces which are acting at a point represented in magnitude and direction by two adjacent sides. Okay. So now we will see the different cases for resultant of two forces. Case 1. So from this diagram, how to consider case 1? First, what is our resultant? R is equal to square root of p square plus q square plus 2pq cos alpha sin alpha. So first case is if the two forces are acting at right angles to each other, that is, the angle between two forces is 90 degrees. So that is alpha is equal to 90. So what is the resultant? So this is a case 1. So simply you substitute instead of alpha, that is 90 degrees, because two forces are acting at right angles. So that the angle between those two forces is 90 degrees. So now R is equal to alpha equal to 90, substitute instead of alpha 90. So resultant capital R is equal to square root of p square plus q square 2pq cos 90 sin 90. So sin 90 1, cos 90 0. So finally p square plus q square is plus 0. So finally R is equal to p square plus q square root of p square plus q square. This is the equation for resultant when the two forces are acting at right angles to each other. So this is about case 1, right? Next, second case, case 2. So what is the case 2 here? So if the two forces P and Q are equal, two forces P and Q are equal, that is P is equal to Q. In such case, what is the resultant? So R is equal to square root of p square plus q square plus 2pq cos alpha sin alpha, and that p is equal to q. So substitute instead of q again p. Okay. So now R is equal to square root of p square plus q instead of q again p, because both are equal, p square plus 2p qp cos alpha sin alpha. So R is equal to square root of 2p square plus 2p square cos alpha sin alpha. So in both the terms we have 2p square common. Take 2p square as common. 2p square of 1 plus cos alpha sin alpha. So this is the equation for resultant of two forces when the two forces are equal. P is equal to Q condition. Okay. So now we will see the angle theta, that is the angle made by the resultant or with horizontal or one of the force P, horizontal force P. So if the resultant makes an angle theta with one force P, that is horizontal force, what is theta value? Theta value you have to determine. So in the same parallelogram law, in the same parallelogram diagram, here theta is equal to angle made by the resultant R with P, OA, that is OA. So AOC is the right triangle, sorry, DOC is the right angle triangle. From the triangle, take tan theta value, write the tan theta value. Tan theta is equal to opposite side by adjacent side from same triangle, that is from triangle DOC. DOC, tan theta is equal to, that is angle DOC is equal to theta. Theta you have to determine. So from triangle DOC, tan theta is equal to opposite side by adjacent side. What is opposite side and what is adjacent side? So refer the figure, that is CD by OD. CD by OD. So what is CD and what is OD? So from the triangle DOC, refer the figure. So here we have already determined CD value Q sin alpha. OD is equal to OA plus AD. OA plus AD. Q sin alpha by OA plus AD. Already we have OA and OD. OA is equal to Q, AD is equal to Q sin alpha from the same diagram. Already we determined the derivation of resultant. OA is equal to P, that is one side. Okay, so substitute same here. Q sin alpha by P plus Q cos alpha. So theta is equal to tan inverse. So tan theta is equal to Q sin alpha by P plus Q cos alpha. So theta is equal to tan inverse of Q sin alpha by P plus Q cos alpha. Okay. So here from the triangle DOC, already we determine OD is equal to OA plus AD. OA is equal to P, CD is equal to Q sin alpha. OA is equal to Q, AD is equal to Q cos alpha. So this is for theta value. If you know two forces P and Q and angle between the two forces alpha, then you can determine the theta value by substituting in this equation. Thank you.